So those were all pretty basic examples. Example 10 and 11, these are a little bit more abstract examples. So let's just combine the differentiation rules to do this. So what are they trying to say here? Well, let me ask you guys first. When you look at this example 10, what rule did you use first? Because I think there's only one correct answer. What's the fundamental rule here that you need? Any thoughts? No thoughts. Okay. Ms. Mario says sum rule. Does anyone disagree with sum rule? Steph says product. Okay, I'm glad I asked. Any other feelings? See, if I were you, like, you might not have a feeling, and that's fine. But if I were you and I was thinking to myself, man, I think we need to use, let's say, the product rule. But you just sat there and didn't say anything, I feel like you're missing a chance to sort of take a chance and say something and then kind of learn from a potential mistake. So that's enough rambling. Let me just tell you what I would do. When I look at this guy and I'm trying to figure out what the basic rule is, I have to say, does K of X fundamentally look more like something plus something, or does it look more like something times something? Because, or does it look like something divided by something? You know, like I would want to look at the shape and try to say, when I look at this, does it look more like this, more like this, or more like this? And when I look at this, it's one term plus some other term. So I think fundamentally it's a sum rule. So we're going to write that down. So this is going to be K prime of X is equal to the derivative of 5h of X plus the derivative of X squared f of X. Now, when I look at the second guy over here, I need the constant multiple rule. So this guy is going to be 5 times the derivative of h of X. And what rule do I need for this part? Hopefully we can see what rule we need for this guy. Oh, Steph, power rule is involved. Did you want to do something before we use the power rule? Jason wants to use the product rule. Steph, can you see how we want to use a product rule here? It's like kind of like something times something, where one of the somethings is x squared and the other something is f of x, like that. Yeah. So now we got to figure out what that's going to be. So what's the derivative? What's the derivative of x squared going to be? The derivative of x squared is just going to be 2x. What's the derivative of f of x going to be? We're just going to call that f prime of x, like that. Okay. So when I go to calculate this guy, it's going to be the derivative of the first thing, which is 2x, times the second thing, which is f of x, plus the derivative of the second thing, which is f prime of x, times the first thing, which is x squared. So you'll notice I didn't write the formula this time. The reason why I didn't write the formula is because one of the functions is called f, and it's confusing as hell if I write f is equal to and g is equal to. So that's why I just kind of did it. It's the derivative of the first thing times the second plus the derivative of the second thing times the first. Okay. So we can simplify this down. I think I wrote my final answer as 5 times h prime of x plus 2x times f of x plus x squared times f prime of x. And this would be my answer. So your answer isn't a number or not even a function. It's an expression that involves the names and derivatives of functions. Is there any questions about this? Anyone want to ask me anything?